So this is the first meeting on the Chapter 9 review, and Chapter 9 is on chemical quantities. So the first question of this Chapter 9 review is calcium carbide, CaC2, is made by reacting calcium carbonate with carbon at high temperature, and carbon dioxide is released. So you're not provided the chemical equation. So the first thing you have to do is to write down the chemical equation. So we have this compound that is going to be made. So that's going to be on the product side. And we are reacting calcium carbonate with carbon at high temperature. So carbon is just C, but calcium carbonate is made of the calcium atom, calcium, ion. And calcium is here, group 2A. So it's going to be a 2+ ion. So calcium is a 2+ ion. And then carbonate, the ending in 8 tells you it's a polyatomic ion. So if we look at our list of polyatomic ion, we can find here the carbonate is located here. It's a CO3 negative 2. So let's write those two formula for the two ions together. And so it's a Ca2 plus, because it's in group 2A, and then the carbonate is CO3 2 minus. You can see from those 2+ and 2- that one of each ion will cancel the charges of the other. So that means the formula is going to be CaCO3. And then we have to decide about the physical state of this. So let's look at the solubility rules. So we do not have calcium listed here in the left side of the solubility rules. However, we do have carbonate. Carbonate makes mostly insoluble compound. Let's look at the exceptions and to see if calcium is an exception. When either of these ion pairs with lithium, sodium, potassium, or ammonium, the compound is soluble. So that means calcium is not an exception, and that means it's going to be insoluble with carbonate. So because it is insoluble, we will write S for solid in parentheses. So that's the calcium carbonate, and it reacts with carbon at high temperature. And carbon, when it's by itself, it's a solid. Think about carbon graphite, or even the diamonds are only made of carbon. But here it's probably carbon graphite that is made to react with calcium carbonate at high temperature. And it says we have calcium carbide made, and calcium carbide is a solid as well. And then we have CO2 gas released. Carbon dioxide is 1 carbon, 2 oxygen, and that's a gas. So that's the skeletal equation because it's not balanced, right? So the next step is to balance it. So for this, we will write down the number of each type of atom we have. So calcium, we have 1 on the left, 1 calcium on the right, 1 calcium on the right here in CaC2. Carbon, we have 2 carbons on the left, 1 in the carbonate here and 1 in the carbon by itself. So that's 2 carbon, and here 3 carbons, because we have 2 carbons in the carbide plus 1 carbon in the carbon dioxide. Oxygen, we have 3 oxygens on the left in the carbonate, and then on the right we have 2 oxygens on the right here. So 2 oxygen on the right. And finally, well, that's it. There is no more other type of atoms, right? Just calcium, carbon, and oxygen. So We can see that the calcium are balanced, so we don't need to change those. The carbonate are, in many compounds here. Actually, in every compound of this skeletal equation. So that's not gonna be easy to balance. But we have the carbon here by itself, so we will keep it. We will balance it in the end using this carbon by itself. So that will make it easier to balance carbon. Oxygen, we have 3 on the left, 2 on the right. And when you have 3 and 2, it's not easy other than making it 6 on both sides. So let's try to make it 6 oxygen on both sides and having multiplied by 2 on the left. And that 2 will go in front of CaCO3 because we want the 2 in front of the molecule that has the oxygen. And so that 2 times 3 here, the subscript, will make 6 oxygen on the left. And on the right, to make it 6, we need to multiply by 3. By 3 on the right, and that 3 will go in front of CO2 here, because that's the molecule that has the oxygen. And 3 times 2, the subscript here is going to be 6. So that balances the oxygen, and it changes the number of calcium and carbon, of course. So, so let's show that this is not the number anymore. So instead of 1, how many do we have? We will have 2 on the left. So 2 on the left, it's 2 instead. So instead of 1 calcium, we have 2 on the left now, and it's still 1 calcium on the right. So we want to make it 2 calcium on the right. So let's multiply by 2 on the right, and that's to multiply the calcium by 2. So let's have a 2 in front of the molecule that has the calcium. So this way we have 2 calcium on the left, 2 calcium on the right. Oxygen, we have 2 times 3, 6 oxygen on the left, 3 times 2, 6 oxygen on the right. So that changes the number of carbon we have now on both sides. So we need to count again how many we have. Let's say that we have no more 2 here on the left, but how many now? So 2 from the carbonate plus 1 here, that's 3. So that's 3 instead here, 3 carbons on the left. And how many on the right? We have 2 times 2, 4 from the carbide, plus 3 here, that's 7. So it's no more 3, but it's 7. 7 carbon on the carbon on the right. So we have carbon in both places here on the left. And so if we want to have 7 on both sides, then we want to have, these 2 from the carbonate and then 5, right? That's going to be 7. So let's make it 5 here so that it's 7 in total. So instead of 3 here, and I will just erase that. Instead of 7 now, we have 2 carbon from the carbonate here, plus 5 here, that's 7. And that should balance the carbon now. So let's make sure. So 2 carbon plus 5 is 7. And then here, 2 times 2 is 4, plus 3 is 7. So this is the actual balanced equation for this reaction. So let's move now to the actual questions, because that was not even asked for, but you know that you need the chemical equation when you do stoichiometry. So the question is, the first question, how many moles of carbon are required to produce 5 moles of carbon dioxide? And I have the equation written again here. How many moles of carbon? So we are looking for moles of carbon, knowing that we have 5 moles of carbon dioxide. So what I like to do is write below the reactant or product what we have and what we are looking for. So here I would like to write that I'm looking for the number of moles of carbon, knowing that I have 5 moles of carbon dioxide. So that shows you, the relationship you will need to focus on. The fact that 5 moles of C react to make 3 moles of CO2. So here it's a mole to mole conversion that is asked for. So it's just that conversion factor that will be needed. So let's write it down. 5 moles of C react to make 3 moles of CO2, right? This comes from that 5 moles of C here makes 3 moles of CO2. So of course, the equal is not a real equal sign per se. It's like equivalent, or you can change it by saying in your head, makes 3 moles of CO2 or produces 3 moles of CO2. It gives you a proportion of CO2 produced from an amount of C, that you start with. And so this is an equality which can be used as a conversion factor. And here, the given amount, what is given to you is those 5 moles of carbon dioxide. So to do the calculation, you will just start with the 5 moles of CO2 and then use this mole to mole relationship as a conversion factor. And because our given amount has moles of CO2 in the numerator, remember when you start with your given amount, it's always in the numerator. So we will want the moles of CO2 in the bottom, in the denominator. So that's going to be a 3 here on the bottom, 3 moles of CO2. And then on top, it's going to be the 5 moles of C. And we can see that the moles of CO2 here will cancel. Right, moles of CO2 cancels, and we have moles of C in the end. Moles of C is going to be our final unit there. So in the calculator, you do 5 times 5 divided by 3, and it's 8.333. So we need to run this to the number of sig figs we have given. And here, the given amount has 2 sig figs, 5.0 is 2. The 5 moles of C per 3 moles of CO2, this is exact. These two numbers will not limit the number of sig figs. These are exact. It's from counting the number of moles. So what limits the number of sig figs is the given amount of 5.0. So we need 2 sig figs. So we will need to stop at the 8.3. So 8.3 moles of C are required to produce 5.0 moles of carbon dioxide. So let's look at the second question. Question B. How many moles of carbon dioxide are produced when 55 grams of calcium carbonate reacts with an excess of carbon? So again, you want to have the chemical equation there. And so it's here. Let's look at it here. So we have grams of calcium carbonate. Calcium carbonate is the reactant here. And it reacts with an excess of carbon. So this carbon here won't matter. And you want to find how many moles of carbon dioxide are produced. So moles of CO2 starting from grams of CaCO3. These relationships, those colorful numbers here are not given in units of mass. They are given in units of atoms or molecules or moles. And so we can read this as 2 moles of CaCO3 will make 3 moles of CO2. So because we are given grams, we will need first to change the grams into moles. And then we can change the moles of this reactant into moles of the product. So the concept map will look like this. We have grams of CaCO3 that is given, 55 grams. We'll change that to moles of CaCO3, and then we can change that to moles of CO2 that is produced using the coefficient from this equation. So let's write down all the equalities we will use. So first, to change the grams of CaCO3 to moles of CaCO3, we need the molar mass. So for the molar mass, we gather the molar masses of each atom. And so let's look at this. We have 40.08 for the calcium, 12.01 for the carbon, and then 16.00 for the oxygen. So 40.08 for the calcium. So let's gather this together. So we have 1 calcium, so 40.08 times 1. 1 carbon, so plus 12.01 gram. And then 3 oxygens, right? So 16.00 times 3. You add this all together, and it's 100.09 grams per mole of CaCO3. Notice how all given molar masses have 2 decimal places. And so because we are adding and subtracting, we're keeping 2 decimal places. It is important here you show all your decimals for the molar mass. All the decimals, following what decimals you had to start with. So this molar mass can be written as an equality, right? Because it's grams per mole, which means 1 mole of CaCO3 is equal to 100.09 grams of CaCO3, right? Mathematically, you can rewrite the molar mass this way. And it shows you how you can use it as a conversion factor when it's written as an equality like this. So that will allow us to change grams of CaCO3 into moles of CaCO3. Next, we will need to change the moles of CaCO3 to moles of CO2. And for this, we will use the chemical equation. And the chemical equation up there tells you that 2 moles of CaCO3 are making 3 moles of CO2. So we can write it like this. 2 moles of CaCO3 are making 3 moles of CO2. And again, we use the equal sign here, but it's really, what it means is that, are producing 3 moles of CO2 or will allow you to obtain 3 moles of CO2. So that's the second equality needed here for the second conversion. So we have all the conversions or all the equality we need. So we can write the calculation, the full calculation. And the full calculation will start with the given amount. And the given amount here is 55 grams of calcium carbonate. So let's write it together. So we have 55 grams of calcium carbonate is the given amount. And that's in the numerator. Because you have grams of calcium carbonate here, you want the grams of calcium carbonate on the denominator of the first conversion factor, right? And this will be coming from the molar mass. The first conversion factor is the molar mass, and it says it's 100.09 grams of CaCO3 for 1 mole of CaCO3. So that cancels grams of CaCO3, and we will obtain moles of CaCO3 doing that. In the next step, you want to cancel the moles of CaCO3. So in the next denominator, we want moles of CaCO3 in the denominator so that we can cancel units of moles of CaCO3. And for this, we will use this equality that says 2 moles of CaCO3. So that's going to be 2 moles of CaCO3 are producing 3 moles of CO2. 3 moles of CO2 on the numerator. And so we can see that units cancel. I'll do it once I have an answer there. So we can show how we are canceling grams of CaCO3 in the first step, and then moles of CaCO3 in the second step. Or maybe let me change the color here to show that's 2 different units here. Oops, I need to be out of here. Okay. So once you do this calculation, the unit will be moles of CO2. And in the calculator, you do 55 grams of CaCO3 divided by 100.09, multiplied by 3 and divided by 2. So the calculator answer is 0. And so let's do it here, 0.8242, etc. And that's moles of CO2. Moles of CO2. Okay, we need to keep 2 sig figs only because of the given amount of 55 grams. You know, the 1 moles are exact, 3 moles of CO2 over 2 moles of CaCO3 are exact. The molar mass has 5 sig figs, so it's not limiting. So 2 sig figs due to the given amount of 55 grams. 2 sig figs means you keep the 8 and the 2. What comes after the 2 is a 4, so you can keep the 2 a 2. And so that's the final answer here. 0.82 moles of CO2 produced from 55 grams of calcium carbonate. So we have another question in that first problem. It's C. How many grams of calcium carbonate are needed to form 598 grams of calcium carbide? So yeah, I didn't do it above, but I really like to show below the chemical equation which amount is known and which amount is asked for. And so here it's asking for how many grams of calcium carbonate. So below calcium carbonate, I like to write question mark, grams of calcium carbonate are needed to form 598 grams of calcium carbide. So under calcium carbide, I like to write the amount that is given. So this time we have grams and we are asking for grams. So this is going to be a full stoichiometry calculation where you go from grams to moles to moles to grams. Of course, in between, you are changing a substance from the beginning to the end. So that's why it is very important that you write your units fully so that, it makes sense why you cancel units. Because as you saw above here, when I cancel grams, it's grams of CaCO3. And then when I cancel moles, it's moles of CaCO3. Right? And then we're left with moles of CO2. So it is important to write your units fully for this kind of problems, because you can go from one substance to another, and you can only cancel if it's grams of the same thing and moles of the same thing. So here we will need to write the concept map, right? So let's write the concept map. Because we start with grams of calcium carbide, we will need to change those grams of calcium carbide to moles of calcium carbide using the molar mass of calcium carbide. Then we can use the chemical equation to change the moles of calcium carbide to moles of calcium carbonate. And once we have our moles of calcium carbonate, we can go back to grams using the molar mass of calcium carbonate. right? So we will need 3 conversion factors, right? The first one will use the molar mass of calcium carbide. So let's calculate the molar mass of calcium carbide. We already know the values for each of the atoms. Calcium is 40.08 grams one time. Carbon is 12.01 grams, and we have 2 carbons. So if you add all of this together, it's 64.10 grams per mole of calcium carbide. Again, we have 2 decimals for both molar masses, so we need to show 2 decimals in the end because it's an addition and we keep the same number of decimal places. So as always, I like to rewrite the molar mass as a mathematical equality because that's helpful to see the kind of conversion factor it will give you. And so mathematically, you can rewrite the molar mass like this. 1 mole of calcium carbide is equal to 64.10 grams of calcium carbide. So that's for the first conversion factor here. The second conversion factor here changes the moles of calcium carbide to moles of calcium carbonate. And so we will use the chemical equation for that. And you only look at the compound in question here, and it's going to be this one and the calcium carbide here. So mathematically, we can write that, I actually have calculated the molar mass of calcium carbonate first. So sorry about that. So molar mass of calcium carbonate is 1 time the molar mass of calcium plus 1 time the molar mass of carbon plus 3 times the molar mass of oxygen. And we already know it's 100.09. And of course, mathematically, it looks like this. So let's get the next thing here. And so that's what we obtain from the chemical equation, and that will allow us to do the second step here to change the moles of calcium carbide into moles of calcium carbonate. And it happens, it's 2 moles of calcium carbonate will make 2 moles of calcium carbide. But even though it's 2 and 2, it is important you show those 2s. I don't want you to remove them and change them into 1s. We need to see where it comes from. And so that's why you need to keep the 2 equals 2. Because we need to see where it comes from. So it looks like with all of this, we have our 3 equalities to do our calculation with 3 conversion factors. And so we will do the calculation starting with the given amount. And the given amount here is 598 grams of calcium carbide. So let's start the calculation with that. Oops, here. So, sorry. So we have 598 grams of calcium carbide. That's the given amount. Everything is in the previous page here. So, okay, because we start with grams of calcium carbide, we want to cancel that unit in the next step. So it's going to be in the denominator of the first conversion factor. And that first conversion factor is using the molar mass of calcium carbide. So it's for 1 mole of calcium carbide on top here. And 1 mole of calcium carbide is here 64.10 grams. So 64.10 grams of calcium carbide goes in the denominator. So this way we cancel grams of calcium carbide. In the next step, we want to cancel the moles of calcium carbide as a unit. So the next step should have the moles of calcium carbide in the denominator. And we are using this equality here. And it's 2 moles of calcium carbide produced from 2 moles of calcium carbonate. So let me change that to calcium carbonate here. So 2 moles of calcium carbonate are making 2 moles of calcium carbide. Moles of calcium carbide cancel. And in the next step, we want to change the moles of calcium carbonate into grams of calcium carbonate. So we will use the molar mass of calcium carbonate, and it's given here. 1 mole of calcium carbonate is 100.09 grams. So it's going to be 100.09 grams of calcium carbonate for 1 mole. And so let's show how we cancel units here. So calcium carbide, grams of calcium carbides cancel. Moles of calcium carbides cancel. And then moles of calcium carbonate cancels. And so we're left with grams of calcium carbonate. So the answer will be in grams of calcium carbonate. So in the calculator, you do 598 grams of calcium carbide. So I like to multiply all numerators together. So times 2 moles of calcium carbonate times 100.09. And then I divide by each denominator. So divide by 64.10. And divide again by 2 moles of CaC2 equals. So the calculator answer is 9.933.7569, etc. And we said it's grams of CaCO3, the unit, right? That's what is left up there. Okay, so how do we run this properly? Every mole number there is an exact number, so it's not limiting the number of sig figs. Here we have 5 sig figs in the molar mass of calcium carbonate, 4 sig figs in the calcium carbide, but only 3 sig figs in the given amount. So the given amount is limiting the number of sig figs to 3. So we'll keep the 9, the 3, and the 3. What comes after the 3 is a 7, so the 3 has to be rounded to a 4. So the answer will be, well, I already had this here. So the answer will be 934, and it's grams of calcium carbonate. Okay, so that's the final answer for this question. And that's the mass of calcium carbonate that is needed, right? That is needed to form 598 grams of calcium carbide. So that's an example of a full stoichiometry calculation where we go from grams to moles to grams of another substance. So this first problem had all kinds of examples. Sometimes it's just grams to moles of another substance, like question B. And sometimes it's just moles to mole of a substance to moles of another substance. So that answers all questions of problem number 1.